Welcome to Data BS, a show dedicated to tackling the big questions impacting the world of data and ML/AI without any of the BS. My name is James Winegar. Each week I sit down with guests from across the data ecosystem to unpack how they're shaping their businesses or the businesses of others through the real-world application of data engineering, ML/AI, infrastructure, analytics, and more. No fluff, unfiltered, but slightly edited to remove noise. This is Data BS. Let's get into it.
Alex, it's nice to have you. We talk all the time. So, how about you introduce yourself?
Hi, I'm Alex. I'm a forward deployed software engineer at MotherDuck. So we're actually renaming that to customer engineer because it makes a lot more sense. So I'm a customer engineer. I also work part-time for DuckDB Labs, and I work with them on mostly blogging, a little bit of documentation, and some DevRel stuff.
Today we're going to be talking mostly about DuckDB, but you can't talk about DuckDB without talking a little bit about MotherDuck. So you're going to have your DuckDB Labs hat on, but then MotherDuck's going to pop in every now and then. So,
Yep, got the uniform and everything.
yeah. So, I really like DuckDB. You really like DuckDB. It solves a lot of the problems we run into, but I think it's probably worth talking about just what is DuckDB, what makes it unique, how is it compared against other database systems, OLAP or LTP. We might even need to talk about that too.
DuckDB is the SQLite for analytics. And so SQLite is famous for being the world's most popular database by a large margin. Orders of magnitude more SQLites in the world than any other database, probably all put together. And it's because it's an embedded database, which means it runs inside the language that's calling it. So if you're running Python code, SQLite is actually just a library. It's inside of your other language. And DuckDB takes the same approach, where it's a database as a library. And so it runs right inside of whatever other language you're using. But it's designed for a different type of use case than SQLite. It's designed for analytics. And that usually means doing bulk operations, things like reading your whole table instead of just grabbing a couple rows, joining really big tables together, doing big aggregates on it. So really workloads that traditionally, well, I don't know if you can say traditionally now, but the last couple of years have been done in data frames. DuckDB ends up being a really good fit for doing that in a SQL-oriented database instead. Other things about it is that it's a traditional kind of relational database. So it's kind of what you'd expect if you were used to, a data warehouse. It's all kind of the same syntax there. It follows Postgres syntax very closely, but it happens to be in this kind of tiny, super easy to use package that you can put anywhere. So you can run it on your laptop. You can run it on a big beefy server. You can run it in a Lambda function, kind of all over the place. So it's a tiny database that runs anywhere. Of course, it's designed for analytics, which also means it's very fast for analytics. So that's another key aspect of it, is that it really is a cutting edge tech in an easy to use form factor. And that's part of the secret sauce.
One of the things is like the concurrency is actually a very similar model to SQLite as well, where really one user on a database at a time. And there's some interesting stuff that MotherDuck has done to kind of manage that a little bit more. But we'll probably get into some of that potentially later. If not, like I did recording with Tino before for MotherDuck that has a lot of that stuff. So I guess like one thing that's important is like kind of making sure people understand like the way that everything is structured from like a organization standpoint. So, can you explain the relationship between DuckDB Labs, MotherDuck, and the DuckDB Foundation?
Absolutely. So DuckDB Labs is a company that's founded by the creators of DuckDB. So Hannes Mühlhausen and Mark Rossfeldt, as well as numerous other folks. There are 15 or 20 folks at DuckDB Labs these days, and they're based in Amsterdam. And they're a company that's all around custom development and support for the open source project. And they're kind of the main stewards and shepherds of that open source project. So if you're an enterprise and you want to use DuckDB internally for a data platform, they're helpful for that. And also if you are a company that's building it into your product, maybe you've got a business intelligence tool or a data workflow tool or a ETL tool, and you want DuckDB as a part of your platform as a service, they can also help with custom integrations or faster bug fixes, things like that. So they're kind of supporting that open source project. The open source project intellectual property is owned by a nonprofit foundation, the DuckDB Foundation. And what's nice about that is, it has a strong shepherd in DuckDB Labs, where there's a whole set of folks that are making it better and better all the time. It's not owned by that company, which means that it can't be bought by another company. It can't really be kind of, restricted in any way. So it's an MIT licensed open source project, and it will remain that way forever. because it's legally obligated to remain MIT licensed, which is really nice, gives you a lot of long-term confidence in a database, because when you choose a database, you're choosing it for a long time. And so you want to have long-term confidence there. MotherDuck, in contrast, is a very close partner with DuckDB Labs, but it's a venture-backed startup based in the US, and we're kind of globally distributed at this point. We got around 50 folks, and we are taking DuckDB into the cloud and building a serverless cloud platform with DuckDB as the engine. We've got a couple different pieces of secret sauce. A large part of it is that we are huge fans of DuckDB, and just, even the core competency of being a DuckDB service in the cloud, we think is a big value already. We also have some other secret sauce around. We've replaced how DuckDB does storage. So typically DuckDB does storage on a single file, which is great on your laptop. It's not great in object storage, because you'd have to replace the whole file even if you inserted a single row, which would not be fun if you've got a couple terabytes. So we've replaced the whole storage engine and built a cloud service around it. And we've got some other secret sauce around running it combined with local DuckDB. So lots of fun, additional things on the MotherDuck side. In terms of the relationship, DuckDB Labs and the founders there own a portion of MotherDuck. So they're co-founders alongside the founding team of MotherDuck, which means that they succeed as MotherDuck succeeds as well. So the folks that created this amazing open source project also get to reap the benefits of the cloud service, which is really what you want to see in open source. In addition, there's a contracting relationship where DuckDB Labs does a lot of things to help MotherDuck. So if there's a new hook that needs to be added, or an area of the code base that MotherDuck is taking more advantage of than the open source side is, they can help prioritize things for us.
Yeah, and I mean, I'm nearly positive that it funds several engineers on the DuckDB Labs side to, be focused on, extending as appropriate to support, kind of the data warehouse, DuckDB service in the cloud model that MotherDuck has.
Definitely helps. I think it's, in many ways, they're really the fundamental experts on DuckDB itself. So it's, they're really great partners.
Yeah. So now I think we got like a good understanding of like DuckDB, MotherDuck, the foundation, et cetera. So today's goal is really focused on DuckDB. So we're going to be mostly talking about the 1.2 release that's coming out, I think, next week. By the time this recording goes out, it might be a couple of days before, or a couple of weeks before. We'll see. But yeah, so what are the major highlights of DuckDB 1.2 to you?
I think DuckDB 1.2, I like to think of the top line highlight as performance improvements in the real world. So DuckDB has really all been about combining research and practicality from the very beginning. It was not designed to be a research prototype. It's designed to be a database for production powered by research. And I think what that has really meant is that they've built a solid foundation and a usable system first, and then they're adding incrementally more and more speed over time, because they already have that really, really efficient core. And so this is one of those cases where they're adding a lot of speed and a lot of really useful cases. So a lot of times where you're doing queries where you're looking at a list of things or doing filters with OR, those are going to now be pushed down into the storage, and those get far more efficient. So a lot of real world queries will just get a lot faster with 1.2. There's also some big benefits with the top N type of calculations, like what are my top 10 customers? Those get quite a lot faster. And if you're dealing with long strings, which database benchmarks famously ignore, a lot of the kind of research around databases tends to think everything's an integer, everything's a float. We don't need to worry about strings. Well, DuckDB is now compressing strings while writing to the database when you're storing it on disk, so you can have long strings and it will be nicer performant there as well.
So yeah, sorry, that's like actually a big deal for me. Is that have impact on the query performance, like read time?
It's really a benefit all around. In general, even on a laptop, our hard drives, our SSDs are a lot faster than they used to be, but they're still slower than CPUs. And that gap is actually, tends to be widening over time. CPUs get fast, and it's hard to get that storage bottleneck. So it's a great trade-off to compress and store, and then retrieve from storage and decompress. Just the reads and writes are faster, and you save disk space.
Overall throughput is higher, basically, with it on the read and the write side. Okay, cool. Sorry, that's actually a big deal for the stuff where I have a use case where we're using MotherDuck and DuckDB. Me and Alex have worked together a lot on some of these things that are actually coming out in 1.2 and 1.1. We had some pretty major things we were working with DuckDB Labs on to try and figure out why, we were running into problems. And so I think like, the team's been very, very responsive to, hey, this is like a real world use case. This is a use case that like is reasonable. And so we should make sure that we can handle these kind of pretty decent sized data sets, and how do we, effectively go through the processing. We had it's pretty complicated, like, out of memory type situation. So, you have to be smart about how the query engine's executing all of that.
You bet. And I think this is a very common workload, especially if you're working with JSON data. JSON data is stored as strings in DuckDB. So if you've got event data, if you've got logs, anything that's JSON format gets a real big boost from this.
Yeah, it's gonna be nice. I'm actually really excited for the customer database that I'm thinking about. Let's just kind of transition into out of memory data sets, and like, with particular to 1.2, how is DuckDB handling it? My table, let's just assume I read the whole thing, and it's 400 gigs, but the device it's running on has 36 gigs or something like that. How is 1.2 going to change like the performance in that situation?
So in general, DuckDB's got a couple kind of ways that it handles that kind of large data set. And it is, I think, a real good differentiator for it. A lot of the data frame tools out there and other things that people use in kind of the ad hoc world for DuckDB, this is a really tough thing. It takes a lot of effort to build, and DuckDB invested, a year or so or more into building this capability. So one is that the engine itself is designed to be a streaming engine. So it's not like a streaming database, but it streams off of disk, which means it reads the data in chunks instead of all at once. So you never have to read all 400 gigs into memory at once. You could process it, one chunk at a time. And with DuckDB, it actually breaks it into pretty small chunks, so you can keep your memory use pretty low in general. It's chunks of like 100,000 rows. So it's really just pulling exactly what it needs off of disk. The second part is that if it ever has more pulled off of disk, or it's doing an intermediate calculation that's larger than it needs, it can buffer data back to disk and say, I've been keeping this hash table in memory, but it's too big, or I have too many of them. So let's put that on disk for now. And in a later stage, I'll read it back off of disk and aggregate it back into my final result hash table. And so that happens in joins and in group by. So it's common. Window functions have separate structures, but they also have out-of-memory support as well. So those intermediate calculations that get spilled, when they get spilled to disk in 1.2, they'll be compressed first. And so that'll be really nice to handle larger and larger structures that can be spilled to disk.
Which is exactly our use case. So we have like high cardinality group bys across like 5 different columns, plus minus. And so like we have these huge hash maps that get built out to support the thing. And anything that improves those processes is fantastic. So I'm excited.
It expands the top end of what you can do on a given piece of hardware with DuckDB. If you were limited by your hard drive space, well, now you can fit 2-3x more on your hard drive while you're spilling. So the total size of problem that DuckDB can handle is taking a nice leap with 1.2.
Yeah, which also means that like the resources that are available to deploy kind of easily in like a cloud provider like AWS, I can start to handle just a bigger workload. And so, with being able to handle that, it's going to allow DuckDB to be very, very competitive with, a lot of the bigger players as far as performance, except for like these, I'm scanning a petabyte of data. Okay, well, how many actually do that, right? There's a whole discussion there on, there's 0.001% of the queries are actually hitting, the tens of terabyte, petabyte kind of range, if you even have that much.
Exactly. And we think there's a lot of cases out there, and you could really take that benefit in 2 ways. You can have a really big beefy machine and now it can do more and more. You can handle really giant problems with DuckDB, or you can run on an even smaller machine than before with DuckDB at even lower cost. So you can kind of pick which benefit you want there. I think that's kind of also kind of core to some of the strategy of DuckDB, which is take a single node as far as it can go and use the disk that's already there to its fullest extent. Because we believe that the algorithms with dealing with disk can actually be far simpler and more efficient than algorithms dealing with many multiple nodes over the network. It also ties back to the pace of improvement of DuckDB. So if you've heard about DuckDB a couple of years ago and looked at it then, you should look again. It is improving at a kind of a crazy rate, especially for a database. They're not simple pieces of code. It's a million lines of code or something like that in DuckDB. It compiles down to 20 megabytes, but there's a lot there. And because there's just a smaller problem space, the improvement rate sometimes it's like 30% improvement per release, and that's a couple times a year. That's wild.
I'm guessing a lot of the work that the team has to do is in, how many threads do I need for this process based on a bunch of like heuristic information and things like that. I don't know. Like I don't get into the internals of DuckDB, but like I'm positive that some portion of it is like, this portion is going to be able to run, scaled out pretty easily based off of, how much data we're talking about. But, I got 8 row groups, so I'm going to use 8 threads or something like that.
Yeah, it's a pretty dynamic way that it breaks these apart. It's really grabbing pieces of work and knocking them out as fast as possible, and having all the cores be able to go ahead and grab it. So DuckDB is very, very good at using all of your cores at once. It's a multi-threaded model, as most modern databases. Postgres is the big outlier, being process-based instead of thread-based. But in general, 3 being thread-based allows you to really split the work out across the cores very well. DuckDB uses morsel-driven parallelism, which is a very dynamic way of kind of on the fly, just grabbing chunks and working on them. Some other types are you actually have to do that in the planning stage, and kind of you have to come up with a plan for 190 some cores before you even start running. And those plans are huge and complicated, but DuckDB allows it to be very dynamic, and just as cores are available to work on more, they grab it.
And streaming the data in is also important when you get into that, because that's like it's another detail you don't have to quite worry about. Unless it's just like, you got 256 cores or threads or whatever, you got 20 gigs of memory. Well, you'll run into issues. But like if you have like what you would expect from the memory footprint for something like that, you should be in a good spot. So what types of problems do you feel like DuckDB solves very well? And then which ones do you think it doesn't solve well based on where it's currently at?
I think the goal is for DuckDB to be a Swiss Army knife. So there's a wide variety in general. It is aimed at those analytical workloads. So I think the kind of original use case for DuckDB was data science. If you're running a Jupyter notebook, you're running an R script, and you're already working in that other language, how could DuckDB meet you where you are and be a database library that you could use? In place of a data frame library, to bring their cutting edge database research into the data science realm. That's a core use case today. Still, it's really a huge part. The other part is it's a really great kind of ingredient for use case. So if you are building a tool or platform, it tends to be a really great component of building a tool. And so there's a lot of creativity that could go into that. There's business intelligence tools that use DuckDB, because anytime you change a chart, I want to now group by and split out one line per company. That's a data operation. And it's an analytical one because it's usually a bunch of data you're working with. So DuckDB is a really great engine for charting. It's also great for kind of ETL type of pipeline workloads. DuckDB can read and write Parquet, can read lakehouse formats as well. And that means it's very good for moving data around in the cloud. It can write to all 3 object stores in the clouds, all the different cloud providers, read from them as well. So you can pull a Parquet file from one cloud, compress it down, reformat it, do any kind of SQL processing on it you want, and rewrite it somewhere else. So it's a great tool for doing this kind of ETL or ELT style flows. Also, it does have some cool query federation capabilities. So you can query a Postgres database directly in DuckDB, and you can then also query SQLite databases, MySQL databases, stuff like that. So it's also got some of that kind of query federation style workload. Kind of a data virtualization is the other buzzword for that that's been around for a bit. But you could do data virtualization as well. So those are kind of cases where I think it's really powerful. I think that at MotherDuck, we're pushing the envelope of it in the core kind of data warehousing use case. DuckDB as an engine is a pretty good fit for that because it's amazing at joins and group by and sorting, has world-class algorithms in all those categories. Some other databases out there are really good at aggregation, but not so good at joins, or vice versa. And DuckDB is actually very well-rounded, so it's good for generic data warehousing as well. The areas where an analytical database in general has a harder time is if you want to be inserting or selecting really small amounts of rows with a ton of concurrency. So you hit on this earlier where it's an in-process database, which means it's really kind of more of a personal database or an individual database and not a used by everybody database.
I think one of the ones just like very DuckDB specific that I think is interesting is DuckDB inside of Postgres. So
We're excited about
so
that.
like yeah. So it's like offload the stuff that Postgres isn't good with to DuckDB because DuckDB speaks Postgres like protocol, like storage protocol too. So it can read write directly like on the same file structure that Postgres is managing. And now like basic stuff, you can kind of, really do Postgres for your database until you scale and or until you get like high volume, analytical workloads because you don't want to run those analytical workloads on your production transactional database because you can run into issues of resource consumption because DuckDB will consume the resources. And so you don't want to get into a capacity management thing. But, there's a lot you can do from that. Maybe read replica, DuckDB on the read replica. That'll take you a decent distance. And then, then you got to look into something else like, a proper data warehouse implementation because, you need multiple users, an integration with a bunch of other things. So that's where, MotherDuck comes into play. But you can have like a really seamless transition as you evolve through that. Life cycle of kind of building out a product and things like that. So that's like one of the ones I'm very interested in. Yeah, conceptually anyways.
I would say it slightly differently, just that Postgres is also having a moment. DuckDB, if you look at the popularity graphs, it's shooting up probably faster than anybody right now. But Postgres is also still shooting upwards, and it's been shooting upwards for decades. It's really having a moment, probably the last 5 years or so, where people have aligned that, open source has reached the level of some of the enterprise databases.
MySQL was the other open source, darling database. Oracle bought it. There's Oracle. There's a lot of people are trying to move to Postgres from Oracle because it's got a lot of the same kind of fundamental viewpoints. You got your SQL server. If you're not doing C# type stuff, the integration isn't there to support you as much. Plus licensing, etc. Virtualization. Licensing has caused people a lot of pain and frustration during audits that they get involved in. And so, having an open source database where you're just like, I run it on hardware and like it's battle hardened pretty well at this point. Community's very good about making sure that no nonsense gets in. So it just continues to get more effective and more effective over time. And so what does that mean? It means that, these proprietary solutions aren't as valuable as they used to be. It used to be that like for a lot of things, you had to run an Oracle database. There wasn't another option. Like your scale was too big. There's nothing else that would have enough juice, or your complexity of your use case was too complicated. Nothing else had enough juice. So
Yeah, I've worked in Oracle land. Not so sad to be not writing Oracle queries at the moment. Postgres is also another similar approach to DuckDB in that it built a solid foundation of extensibility and reliability and transactionality, and they're adding the speed on over time. So Postgres is getting faster with each release. MySQL is actually getting slower. Every release,
yeah,
MySQL gets a little slower, which is kind of wild to think about. I'm spoiled in DuckDB land. Stuff just gets like so fast all the time. But DuckDB has a couple cool ways to tie into Postgres. You can use the Postgres scanner. So you can read and write to Postgres as if you were like talking to Postgres through any other kind of client connection, which is very powerful. And it can be transactionally safe. So you can actually read and write to Postgres within transactions in a whole separate database. Pretty wild. But even more wild is that there's now an extension for Postgres called pgDuckDB. And this actually embeds DuckDB in a Postgres extension. And that starts to really open up the seamlessness where you can just connect to a database like it's Postgres and DuckDB takes over the execution. And it's really a new level of seamless. So it's in beta. Try it out.
what are you really looking forward to coming out of DuckDB this year? As we will look towards 1.3 and things like that.
I think there's a lot of exciting things. In general, the DuckDB roadmap is kind of by design pretty fluid. So there's a lot of opportunities where, as you have a use case where you're stretching DuckDB, reach out, talk to the DuckDB folks on either Discord or on a GitHub discussion. And I think there's a lot of cool directions to go in. Some of the ones I'm excited about are there's plans to add an ODBC scanner, much like the Postgres scanner we were talking about. So essentially, you could, from DuckDB, connect to DuckDB, you could then reach out and query a wide variety of other databases like Oracle, like SQL Server, like IBM DB2 through their ODBC drivers. So suddenly you can easily pull data out of those legacy systems and into a system that's much better for analytics, and do it all in SQL without a full separate ETL flow with some separate tool. You could actually have a SQL statement, select star from IBM DB2, insert into DuckDB, or insert into Parquet file in S3. So really pretty cool workflow engine for moving from legacy or more transactionally oriented databases into the analytical world of DuckDB or Parquet on an object store, data lake land.
I was just thinking about how you also have to be careful when you use like an ODBC scanner against like those other systems. For the same reason we were talking about with Postgres, give resource contention. This is my old select star from a production database message. Make sure you try to do an incremental load to try to add the caveats for that. Only grab the stuff you need. It's row based, so it's not as big of a deal on the star side. But the don't grab the whole table. You're gonna blow out the buffer cache on those systems. And so, still being thoughtful about the approach, but it really means that like you can do the fast paced analytics that you couldn't really run on Oracle directly for whatever reason. Because when it does the aggregation, it's very expensive because it's a row-based system. There's things you can do there, but like, we bring it over to DuckDB, it's for that purpose. And as long as you're not, getting, some craziness over the wire, you got a 10 gig, thing that you pull over, it's going to take a few seconds and you'll be done. And then you do what you need to do from that. So if you got like, look at the last 30 minutes of data, is there anything I need to take an action on? Yes, no, boom. Those types of queries, I think will be, you can offload off of the Oracle execution engine, run it from like a server that's next door to it, and really stretch out your Oracle database more effectively, or your SQL Server or whatever.
You bet. Absolutely. I think one of the patterns that I really like for that is have a periodic job to grab data in bulk, hopefully from a replica. But then if you really need up-to-date data, combine the bulk data that's already in DuckDB with the latest and greatest from the transactional system. So use the transactional system for what it's good for. Just get me a tiny bit of exactly what I want and combine it with your historical data that's in efficient DuckDB format. And I think it's a cool pattern.
Yeah, we'll take it one step further. Get the latest thing from the DuckDB side, and then when you go back out to the Oracle side or whatever, now you have your watermark to move across. And so
pass the filter.
Yeah. So now you don't have to do deduplication or anything else reasonably if you have a field you can use to distinguish that, like an updated timestamp or something.
You bet. Absolutely. I think it's very interesting because it's the real world, right? The real world is these databases have been around and they will be forever. So that's one. I think another is really around data lakehouse formats. There's a lot of work going on in the data lakehouse space around catalogs, around Iceberg, around Delta, and DuckDB is heavily involved there, really with all of that. And what folks are finding, if you're building a catalog and you want people to be able to use it, easiest way is to build support for DuckDB rather than having to run another service to go operate your catalog. So DuckDB, I think, is actually going to be a really great way for catalogs to drive adoption because it's so easy to use. So lots of exciting stuff in the catalog space.
I don't understand the connection there off the top of my head. So what's the primary driver for why supporting DuckDB helps manage the catalog more effectively?
If DuckDB can read your catalog, it just opens it up to be much easier than if you had to run something like an AWS Glue to go work with a catalog.
Okay. So basically, like because DuckDB is in process, you can run it kind of wherever you need to run it, and then like if your catalog supports DuckDB, then you can make your deployment strategy like not as complicated.
Yes. So the catalog will still be managed somewhere separately and operated, but it's much easier to connect to and consume from that catalog.
Gotcha.
It's DuckDB compatible.
And this kind of ties into, I think, what Databricks was doing with DuckDB. Is that Unity catalog working with DuckDB to then like expose basically everything from there?
There's a good partnership there for sure. And that's part of the benefit is, the DuckDB ease of use and accessibility with the ability for a catalog to work for a whole organization.
Awesome.
So lots of fun stuff there. I think there's just continuing to be more and more other fun stuff with DuckDB. So lots of other goodies there, but I think those are a couple for sure. And another area that we're really excited about as well are community extensions for DuckDB. So extensions have been a part of DuckDB for a little while. Some of the core capabilities that folks love about DuckDB, like the Parquet reader and writer, have been an extension for quite a while. But more recently, these extensions can now be built by anybody in the community. And it's a lot simpler than before because there's a template on GitHub that you can clone, and it comes with it with a CI/CD workflow that will compile everything and test it on all the various platforms. And you can even then, once you've got it all tested in your own repo, you can actually commit just a description and a link into another repo, and DuckDB will actually do all the distribution as well. So they'll publish it for all the releases that you have, and people can actually treat it a lot like Python's PyPI, the Python package index. And they can actually just say, install package from community with any DuckDB. It'll automatically download the binary that you need, and you're up and running in a couple of seconds.
Is there a configuration option to turn that off?
You bet. Yeah, there's yes. So in all these things that we've talked about, DuckDB is, I think, by default designed to be very open. It's a Swiss Army knife. The goal is to let you pull data from wherever you'd like. If you are building it into a system where you do want it to be an engine that does a specific task, there are lots of ways to lock things down. I think at least one of those was a request that I made back in my Intel days. I was like, could you let us turn that off, please? They cheerfully obliged. It was really helpful for us. But yes, you can use that only if you really want it. But yes, that's really exciting. So DuckDB is, in my opinion, a little biased, the world's best single player or single use database. It's amazing. Wherever you can place it, it's going to turbocharge that workflow, whether it's you on a laptop or you're building in an incredible, powerful, giant ETL system. It's the best ingredient. However, DuckDB is also pretty cool in that there's a page on duckdb.org. It's, why DuckDB, and it includes cases for why not DuckDB. And it explicitly lists data warehousing as one of the cases where DuckDB is not built for that. And it's because of its single process nature. So what we've done at MotherDuck is taken the amazing parts of DuckDB and we've extended it so that it's also an amazing choice for data warehousing. So by having it be a cloud platform, you get the lovely syntax benefits of DuckDB. It's the easiest, friendliest SQL to write. You get that fast execution, that scalability, spilling to disk, all that type of stuff. But we're also trying to add a lot of value in the service layer. So it's it's common most of the time you see a cloud platform on an open source project. It's fairly similar. They're gonna run it for you. But in this case, there's a lot of components that MotherDuck has added. DuckDB has no concept of a user because you're in process, which means there's no permissioning. And if you've been a DBA or you've administered a cloud data warehouse, you don't really want to share everything with everybody. Generally, you want to have some security. So MotherDuck, for example, allows access control. It also allows you to do things like have each person using your database have their own compute environment. So that way you can allow them to work totally independently and not step on each other's toes. There's a lot of benefits to the service architecture that MotherDuck has there. So a lot of fun there.
The serverless approach to data warehousing with this, I think, is another valuable piece.
The serverless approach, I think, is definitely huge as well. It's part of our mantra is to be easy data over at MotherDuck, and serverless just makes it very easy to spin up just as you need it to only run the compute workloads that you need. And by having it be by individual, it's really allows for nice workload segmentation. It allows for just a lot of nice benefits that way. So that serverless aspect is a huge win as well. The last kind of part of our secret sauce is the what we call dual execution. We used to call it hybrid execution. Now we call it dual execution. There's a lot of other things that use the term hybrid. So for us, that means when you connect to MotherDuck, you use the DuckDB driver you already have. So if you're in Python, you've already pip installed DuckDB, or if you're using ODBC, it's already ODBC driver. And that will actually form a bridge between your driver and MotherDuck. But what's unique about DuckDB is that driver, that ODBC driver, it has the whole database engine in it. And so wherever you're running, you have an engine in the cloud, a MotherDuck, and an engine locally. And that could be locally in your GitHub action, somewhere in the cloud, in your Lambda, or on your laptop.
Pick wherever you want it, basically.
Pick wherever you want it.
So, Alex, what's it like working in MotherDuck and what roles are currently open there?
It's a whole lot of fun. I think where I worked previously was, giant company. Tons of great people, really enjoyed my time there. But working in MotherDuck is great for the community aspect to get to really know everybody. I could just get help from everybody, and it's a very collaborative environment, which is really exciting. There's a ton of variety because we're moving fast. It's DuckDB moves fast, MotherDuck moves fast. We're building a lot of fun things, and I think it's, for me in particular, I'm a fan of the technology. I'm a fan of the approach. I'm a fan of kind of the vision, and it's so easy to work somewhere where you're a fan of it. It's just like, I feel so lucky and fortunate, both on the MotherDuck side and the DuckDB Lab side. Like, this thing I'm a fan of, I get to work on every day. It's just so great, and I know it helps folks. It's legitimately more efficient, more cost effective, faster than what they'd be doing otherwise. So it's easy that way. In terms of positions, we've got some on the software engineering side, kind of in the platform side, and a couple other kind of software engineering roles there. We're also recruiting on the product side, so bringing in some expertise in product management specific to databases, and a couple other spots. So take a look at MotherDuck.com. We got a careers page. It's a really fun place. One of our values as a company is unorthodoxy. So if that's you, come on down. I think that adds to our culture of being really collaborative. Is that the best way to work together is to accept viewpoints from all over the place, and unorthodoxy is, I think, a fun part of that.
Yeah. I mean, I really enjoy working with everybody on the MotherDuck team. We talk like a couple times a week. So, it's a pretty connected environment. So back to DuckDB, my bad. So how can people get involved in contributing to DuckDB? We talked GitHub, we talked Discord. Is there anywhere else that makes sense?
Those are great. The community extensions are also a really great way to jump in. I think of Python, in many ways has been an amazing wrapper language. People building AI and ML models aren't writing C++, they're writing Python that calls C++. DuckDB could be the same, where you can write SQL to call into C++. So you've got any kind of cool C++ library that you want to wrap. DuckDB allows it to work in any language, Python, R, JavaScript, all over. So
that's an interesting, like, it's the foreign data, or it's like the foreign data wrapper, but down into a C++ library instead of like a function call. It's interesting.
It's kind of like that. It's kind of like how WASM can be this kind of universal compile target, where you can use it all over, same underlying library, same way in DuckDB extensions. So I think that's a really cool area where folks can jump in. I am not a C++ programmer, but I've been able to do a little bit to help with some extension stuff. So even if you're not a C++ person, the CI/CD, the compiling part, the hard part just works.
Yeah. The hard part's the build. Like if you've never set up a build engine for C++, it's very complicated. But since they already do all that work for you, all you have to do is write some code. And we live in a world where basic stuff you can get a lot of help with from like ChatGPT and things. So as long as you're not doing like crazy or state of the art, like you can actually learn a lot and get community feedback by contributing to an extension. So if you're wanting to learn and you got a cool idea, maybe that's a good idea too. So what would you say are the key takeaways for people listening about DuckDB?
I think with DuckDB, try it out. It's MIT licensed. It's free. It is incredibly popular for a lot of good reasons. It's designed to be fast, but more importantly, easy. And there's a lot of databases that are the other way. More importantly, fast, easy where they can. But DuckDB is easy first, and you feel it. And it's really just a joy, I would say, to work with DuckDB, especially in contrast to the databases of yore, the ones in the past. So it's fast and easy.
A good example there is like CSV reader. Like reading CSVs in DuckDB is a joke as compared to like basically anything else. And it tries to do a good job of determining all the details. So, that's a great example. Go look it up. If you work with CSV files and you hate it, like go look at DuckDB. It'll make your life easier. So where can people stay updated on DuckDB's latest news and features and community development? Is that Discord, GitHub?
Discord, GitHub are great. There's also a MotherDuck newsletter that also covers the full DuckDB ecosystem. So that's another great way to kind of subscribe and kind of every month or so get a real great download of what's been happening in the industry. There's also, you can follow on Twitter, Blue Sky, those type of places.
Awesome. All right, Alex. Well, it's great to have you. Hope you have a great day.
You bet. Cheers, folks. Happy analyzing.
That's it for this episode of Data BS. If you enjoyed this episode, make sure you subscribe wherever you listen to your podcast and not miss the next one. This episode was sponsored by Corrdyn, a data consultancy that helps organizations unlock the power of their data. If you have a data challenge, we can help. Visit Corrdyn.com, Corrdyn.com, to learn more. See you next time.